Look at this electric bill. July, $318. This is not a mansion. This is a mobile home. You are living inside a thin metal box baking under the Arizona sun, the Florida heat, the Texas summer, and you are paying $300 just to survive in it every single month. Now here is what nobody told you. NASA figured out how to protect astronauts from temperatures ranging from negative 273 degrees Celsius to positive 238 degrees Celsius. Not with thick foam, not with fiberglass. With a material so thin, you can fold it and put it in your back pocket. That same material is sitting on a shelf at Home Depot right now for under $30. It reflects up to 97% of radiant heat. The U.S. Department of Energy has studied it and confirmed it works. And nearly all of the 20 million Americans living in mobile homes have never heard of it. In this video, I am going to show you exactly how to install it, step by step, dollar by dollar. But first, drop one word in the comments right now. What state are you in? I want to know who is getting cooked the worst this summer. Because where you live changes everything about how you do this. Here is a number that should make you angry. Nearly 20 million Americans live in mobile homes right now. That is not a small group. That is the entire population of New York State living in manufactured housing. And the average summer electric bill for a mobile home in a hot climate runs as high as $350 a month. Not because mobile homes are inefficient by accident, because of how they were built. Thin metal walls, low-grade roof panels, minimal insulation, framing that conducts heat like a highway. You are not living in a home that was designed to stay cool. You are living in a structure that was designed to be affordable to build, and someone else decided that your comfort in July was not part of that budget. But here's the part that nobody talks about. When radiant barrier technology started gaining real traction in residential housing, the fiberglass and cellulose insulation industry saw it as a direct threat to their market share. Companies that had been selling you pink, fluffy insulation for decades launched campaigns to discourage builders and consumers from adopting it. Think about what that means. A material that reflects up to 97% of radiant heat, confirmed by the Department of Energy. Inducted into the Space Technology Hall of Fame in 1996, and the industry response was to bury it. Not because it did not work, because it worked too well. It was too cheap, and nobody could charge you a monthly fee for it. Let me take you back to the 1960s. NASA had a problem. Astronauts in space faced temperature swings that would kill a human being in minutes. On the sunlit side of a spacecraft, surface temperatures can hit 250 degrees Fahrenheit. On the dark side, they drop to negative 250 degrees Fahrenheit. Traditional insulation would have required a layer 7 feet thick to handle that range. That was obviously not an option on a rocket ship. So NASA engineers developed a different approach entirely. Instead of trying to slow down heat through thickness, they reflected it. A thin layer of aluminized material, originally developed under contract for Marshall Space Flight Center in the mid-1960s, became the foundation for what we now call radiant barrier technology. It was used on the Apollo spacecraft. It was used on spacesuits. It has been used on nearly every NASA mission since then. And here is the physics that makes it work. Heat moves in three ways. Conduction, which is heat traveling through solid material. Convection, which is heat carried by moving air. And radiation, which is heat energy moving through space as infrared waves. Your fiberglass insulation handles conduction and convection. It does almost nothing against radiation. On a summer afternoon, your mobile home roof surface can reach 150 to 160 degrees Fahrenheit. That superheated roof is radiating heat downward into your ceiling, exactly like a pizza oven element radiates heat onto the pie below it. Your AC turns on and runs because it is fighting radiant energy that your current insulation was never designed to stop. Radiant barrier stops it at the source. Independent research published in Energy and Buildings Journal by Dr. Mario Medina at the University of Kansas measured summer heat flow reductions of 42% through the ceiling in homes with low insulation levels. That is exactly the insulation profile of most mobile homes. The National Renewable Energy Laboratory ran experiments on manufactured homes from 1988 to 1991 and documented a 31% reduction in energy usage after retrofitting. The Department of Energy confirms radiant barriers reflect 90 to 97% of radiant heat and reduce attic heat gain by 25 to 40% in hot climates. This is not a blog post. This is not someone on YouTube guessing. This is peer-reviewed science and federal research. Here is exactly what you need and exactly what to do. You are going to need 3 things from the hardware store. First, perforated radiant barrier foil. Buy the single-sided version to start. It runs between 10 cents and 25 cents per square foot. For a mobile home with roughly 1,000 square feet of floor space, you are looking at $25 to $50 in material. You can find it at Home Depot, Lowe's, or search perforated radiant barrier foil roll on Amazon. Make sure it says perforated. The tiny holes prevent moisture from getting trapped. Second, a staple gun and half-inch staples. If you do not own one already, it is about $15 at any hardware store. Third, foil tape, not regular tape, actual foil tape. Around $8 a roll. This seals the seams and keeps everything locked in. Total materials budget for most mobile homes, under $80. Now here is where you put it and in what order. Location number 1 is your roof cavity. This is where you will get the biggest return. Go into your attic or roof space and staple the foil to the underside of your roof rafters with the shiny side facing down toward your living space. Work in rows from one end to the other. Overlap each row by at least 2 inches and seal every seam with foil tape. The single most important rule in this entire process is this. You must maintain an air gap of at least 1 inch between the foil and any surface. The air gap is not optional. Without it, the barrier cannot reflect. It just conducts. This is the mistake that makes people say it did not work for them. Seal every seam. Do not skip corners. The whole job for one person on a standard single wide takes 3 to 5 hours. Location number 2 is your underbelly. Mobile homes lose and gain heat from below as well. Wrap the foil around any deteriorated or exposed belly board on the underside of your home, shiny side facing outward, and tape all edges down tight. This is especially important if your belly wrap is torn or sagging because you are losing temperature from the floor year-round. Location number 3 is your ductwork. Your AC ducts run through spaces that can reach over 130 degrees in summer. Every foot of uninsulated duct in that heat is losing cold air before it ever reaches your room. Wrap the ducts with radiant barrier foil and tape it snug. This one step alone can noticeably reduce how long your AC runs each cycle. Total time investment, 1 weekend. Total cost, under $80. You do not need a contractor. You do not need a permit for this. You need a staple gun, foil, tape, and about 4 hours of your Saturday. I am going to be straight with you about something because I think you deserve an honest answer, not a sales pitch. This is not a miracle solution. It has limits, and you should know them before you spend $1. Radiant barrier works best in hot, sunny climates. If you are in Minnesota or Maine where you spend most of your energy budget on winter heating, this is probably not your highest priority investment. In cold climates, the Department of Energy recommends focusing on adding more traditional insulation and sealing air gaps first. The math just works out differently when your main enemy is cold rather than heat. Dust is also a real factor. Over time, dust that settles on the foil surface reduces its reflective performance. Installing the foil with the shiny side facing downward, away from the direction dust falls, extends its effectiveness significantly. And I want to be clear about the numbers. One study estimated total annual electricity bill savings for a Florida home at 3 to 6% after installation. That sounds modest, but that number is for a well-built house with existing insulation. For a mobile home with minimal insulation where radiant heat is the dominant problem, the impact is proportionally much larger. The University of Kansas research showing 42% heat flow reduction through the ceiling was measured in homes with the same low insulation profile as most manufactured housing. Do not expect your bill to drop to 0. Expect it to drop meaningfully, and expect your home to stay cooler longer before the AC kicks in. That is a realistic promise, and I would rather give you that than oversell something and have you feel misled. Let me zoom out for a second. We just covered a technology that NASA developed in the 1,960 seconds. that the Department of Energy has confirmed in research, that the Space Foundation inducted into its Hall of Fame. That reflects 90 to 97% of the radiant heat that is cooking your mobile home from the inside out. And it costs less than a tank of gas. So why did 20 million people living in manufactured homes in this country not know this exists? Because there is no subscription model for aluminum foil. There is no service contract. There is no technician who needs to come back every season. You buy it once, you install it in a weekend, and it keeps working for decades with no moving parts and no maintenance bill. The people who profit from your $318 electric bill need that bill to stay at $318. The insulation industry that pushed back against radiant barrier in the 1,980 seconds was not protecting consumers. It was protecting margins. Here is what I want you to take away from this video, regardless of whether you ever install this material. Heat is not just one thing. It moves in three ways, and most people are only defending against two of them. The moment you understand that radiant heat is a separate problem that requires a separate solution, you start seeing energy efficiency completely differently. You stop buying more of the same thing and start asking whether you are solving the right problem. 93% of the energy the sun delivers to Earth arrives as radiation, not conduction. Not convection, radiation. Your fiberglass insulation is fighting the wrong battle every single summer day. The three things to remember from today. 1. Radiant heat is the primary reason mobile homes overheat in summer, and fiberglass alone. 2. Perforated radiant barrier. Foil reflects 90 to 97% of that heat and costs under $80 to install in most mobile homes. 3. You must have an air gap of at least 1 inch on one side of the foil, or it will not work. That one detail is everything. If this opened up something you did not know before today, subscribe. Every week, I dig into the things that actually work, backed by real research, priced for real budgets, and explained without anything being sold to you. And if you are already living in a mobile home and you have dealt with these summer bills, drop your monthly number in the comments. Let people see what this actually costs real Americans in the real world. Because the more people who know, the fewer people who keep paying for a problem that has a $30 fix sitting on a hardware store shelf right now.